So we are looking at a block of mass 1 kg moving on a horizontal surface with the initial velocity of 2 meter per second. It enters a rough patch ranging from 0.1 meter to 2.01 meters. That's a weird number. Okay, I hope I didn't copy this wrong. The retarding force Fr on the block in this range is inversely proportional to x over this range. The block is inversely proportional to x over this range. Okay. Okay, so they're given, yeah, less than. So before and after, okay, let me put the diagram that will make it clear. I'll do it here. So we have the block sliding through the space. So the value that they have given, it's not a typo error, it is so. So in this space, there is a positive kinetic friction given by, okay, the force is given. So this is non-zero. And here it is 0. It's smooth. But here it is not so. And here again it is smooth. So the resistive force here is 0, my bad. And here it is negative x by k by x, 0 again. Then, okay, so that's that. So this is with a mass of 1 kg and with a velocity of 2 meter per second. And yeah. So here what happens? It's encountering the frictional force. And of course, when it comes out over here, its velocity would have reduced, right? What is the final kinetic energy and the speed of the block as it crosses this patch? Okay, so how will we go on doing this? So we're going to make use of work energy theorem. Okay, so as per work, the statement and all, I'll let you guys write. In exam, you have to write this pura statement and everything. So full-fledged statement you guys have to write, and then you end up with the expression. Okay, so we are looking at the kinetic energy, initial and final and everything. So let's see what happens. Since we have the expression for the force, we can figure out the kinetic energies. So we have half mvi square over here. Sorry, my bad, what am I telling? Since we have the velocity, initial velocity, we will be able to figure out 2, if I am right, 1 kg and 2 meter per second. And so we have this to be 2 joules. Next, work done by. So with this, we'll be able to figure out how much energy is consumed of. It's so simple, right? Then subtract that value with this and you'll be able to figure out the velocity after that. So we have F xis xf x dx, right? That's your formula. So this would be, it is moving from 0.1 to that weird value, 2.01. Force is minus kx, minus k by x. I think it's k by x. Yeah. Into dx. So this is to do with log minus k log of x, 0 to 1, 2.0. Okay. This is minus k without, yeah, we need to make use of. Okay, guys. So how did I get this value? So you need to watch log a minus log b is log of a by b minus k is common for both. So I did this math. Again, I won't be able to help you guys with this. All this basics you need to have learned. Natural log of 20.1. It's approximately 3. 3. Yeah, 3. And we need to substitute k value as well. K is 0.5. So minus 1.5. 3, right? Yeah. Minus 1.5 joules. So this much of energy is gone. So what is the final kinetic energy? Oh, sorry. What is the, therefore, change in kinetic energy will be final minus initial. Wait, what am I doing? No. It's not, okay, my bad. And this is supposed to be equal to work. Okay, now it's right. So we don't have space over here. Kinetic energy final will be equal to work plus kinetic energy initial. So initial is 2, this is minus 5. Yeah, now it's proper. 0.5 joules. I got a bit confused. So this is your statement theorem, right? This statement I already written, work energy theorem. So as per that, I am able to. Now, with all of this data, since I know the final kinetic energy, all I have to do is make use of, we know that, or we already written all of this. So V final square is 2 times of kinetic energy final divided by mass. So yeah, you calculate this and V of F will be equal to some meter per second, and that would be your answer. Okay, yes. So quite simple. So don't get confused with the function over here. You just have to use integration. Whenever you get any such varying functions, it's to do with integration. What is the final kinetic energy? Oh, that had to be found. I was trying to find only the speed. Okay, anyways, done that.